right? So when you have equations with a square root like this, or like any of those 12, okay, if it's any of the 12, those type of equations, we call them square root equations, okay? Or you can call them equations involving what? Square root. So the way you solve it, okay, you have to eliminate the square root sign, okay? You have to eliminate the square root sign in order for you to solve for x. And the only way that you can do that is by make sure that you isolate the square root first on the left-hand side. Then you square both sides to eliminate it. Okay, so if I do an example like, okay, let me start with number 2. Maybe I can do that one and then a complex one. All right, so I'll start with a simple one. Square root of 5x plus 6 equal to x. So that's number 1. Square root of 5x plus 6 equal to x. Now, this is probably the simplest of this type of equation that you can get. So it's very straightforward. The square root is isolated. Okay, the x is on its own on the right hand side. So the next step would be to square both sides. Okay, we square both sides to eliminate the square root sign. So on the left, we end up having 5x plus 6. On the right, we end up having x squared. Now, since we are focusing on quadratic equations, it means I have to form the standard form of a quadratic equation. So I'll take the 5x to the right, the 6 to the right. I'll get 0 equal to x squared minus 5x minus 6. Once you get there, you are spoiled for choice now in terms of how to solve for x. You can use factorization or you can use the quadratic formula. Fortunately, this trinomial can be factorized, so it will be x minus 3, so x minus 6 will be x minus 6 times x plus 1. Okay? So what this means is I'll get two values of x. Please take note, I'm not going to say I'm going to get two solutions yet. I'll just say I'll get two values for x. Then I have to test both values if they are really valid in terms of the square root. Because if you find the square root of a number, you must always get a positive, and there must be a positive number on the right hand side. So you have to do some checking. Every time you solve a square root equation, you have to check if both the values of x you got after solving the quadratic equation are valid for the square root equation. Yes, for the quadratic equation, these will be the solutions, but they may not be the solution to the square root equation. Please take note of that. There are solutions to that quadratic equation, but it doesn't mean that there will be solutions to the square root equation. Therefore, you have to do some kind of test. Okay, the test is very simple. So let's just do some checking. This can be done mentally, by the way, because there is no mark allocated for it. So we put x equal to 6 there. If I put x equal to 6, I'll get 5 times 6, which is 30 plus 6, I'll get 36. This is going to be equal to 6, so I'll get 6 equal to 6. So what this means is, indeed, x equal to 6 is a solution to this square root equation. Okay? Then, if I try minus 1, if I put minus 1 where there is x there, I'll get minus 1 times 5, it gives me minus 5. Minus 5 plus 6, I'll get a positive 1. So I'll get a positive 1 equal to minus 1. Now I've got a problem here because the square root of 1 is a positive 1. So this can be. Okay? Which means this is not a solution. X equal to minus 1 is not a solution because it's causing us to have a positive 1 on the left or a positive number inside the square root sign and a negative number on the right hand side because x is negative 1. So what this means is we only have one solution, and that solution is going to be x equal to 6. that x equal to 6 there is our solution. X equal to -1 is not a solution. Okay, so this is very simple, right? Now let's move on to a more complex one, a more complex question. Let me check this one. That one. Right. Fortunately, or unfortunately, I don't have this. So let me start from here so that I can write. So it's 5x plus 1 equal to the square root of 5x plus 1. Then there's a plus 12 outside the square root. Okay? So the first thing is to isolate the radical sign or the square root sign. So here I have to take the positive 12 to the left-hand side. Please be aware that the 12 is not inside the square root. Okay, it's not inside the square root, but the positive 1 is inside the square root. So just take the 12 to the left, you get 5x minus 11 is equal to the square root of 5x plus 1. This is the same as the square root of 5x plus 1 is equal to 5x minus 1. Okay? Please, I hope you won't ask, no one is saying, how come we don't have a negative? I think I explained that, isn't it? Yes. Huh? Did I?
Please explain that step.
Okay. First, I took the positive 12 to the left. So this 1 minus 12 will give us minus what? 11. Right? Then, since 5x minus 11 is equivalent to square root of 5x plus 1, generally the square root must go on the left-hand side. So I can just swap their positions. There is no need to change any signs. Huh? Oh, okay. It's supposed to be a plus. Sorry, it's a minus. Sorry, I didn't put the second one. Sorry for that. I didn't put the second one. Okay. Now I see why people were asking. Okay, I didn't put the second one by mistake. Sorry for that. All right. So are we all clear there? Then from here now, we have to square both sides. Now, when you are squaring both sides, please be aware that this 5x minus 11, it's one number. Okay, it's one number. Though this is a binomial, but you treat it as one, so you must put the 5x minus 11 inside brackets. Because if you know the value of x, you substitute it there, you get one number, isn't it? Yeah, so you don't treat the 5x, okay, separately from the minus 11 and vice versa. You treat the 5x minus 11 as one number. Right? So what that means, I think I can use this space here. Okay, I've got that space. So from here, we have the square root of 5x plus 1 all squared is equal to 5x minus 11 in brackets squared. Please take note of that. Right? You don't square it like this. Please, this is not allowed. 5x squared. Then you say minus 11 squared. This is incorrect. This is incorrect. Okay? So if you have got a binomial on the right hand side, you treat it as 1. So you put it in brackets, then you square it. Okay? Now, you remember when I told you about perfect square trinomials? Do you remember? Now, to simplify the right hand side, you get a perfect square trinomial. Okay? So we end up having 5x plus 1 equal to, so this will be 25x squared, all right, If I multiply 5x minus 11, then I multiply that by 2, the product by 2, I'll get the middle term, which is going to be 110x. Then I'll square that, I'll get positive 121. Okay, if you think you cannot do that, then use FOIL. Okay, if you use FOIL, then you should have 5x minus 11 times 5x minus 11. Then you can use FOIL. But because I know that I should get a perfect square trinomial, it's very easy to get the perfect square trinomial. You square this 5x, you get that. The middle term now, it will be 2 times the product of 5x and 11. So if you multiply 5 times 11, you get 55 times 2, you get 110. Then the third term of the trinomial is a perfect square. You just square the 11, but you must put a plus here. Here we must have a minus because of this minus. Okay, I'm going back to the basics of perfect square trinomials. Okay, if you can't do that, then you go via this way. Go back to grade 9, use FOIL. But it can take you a little bit of time in terms of your time management. But be aware that there is no mark allocated for using FOIL at this stage in grade 11 or in metric. No mark is allocated for using what? FOIL. Okay? Alright, so from here, we take the 5x and the positive 1 to the right, so it's 0 equal to 25x squared. Then that will be minus 115x, right, plus 120. Okay, I've got a common factor, okay, which will be 5, but I think, let me just use the quadratic what? Formula. Okay, because the coefficient of x squared and the x, they are quite large, yes? No. If you take the 5x, it becomes negative, so you get minus 115x. Isn't that so? Yes. Okay, so then we use the quadratic what? Formula. In this case here, to avoid making unnecessary silly mistakes, I would recommend using the what? The quadratic formula. That would be the best way to go. Okay? We can also simplify the coefficients, which is what I'm going to do now. Check out the common factor. So I'm going to factorize by a common factor. Okay, that will be 20, 5 in the 20, that will be 23x. Into that will be 24. So eventually, my equation, if I divide both sides by 5, I'll get 0 equal to 5x squared minus 23x plus 24. Right? Okay. Let me use the quadratic formula. So this will be x equal to minus b plus or minus b squared minus 4ac all over 2a. All over 2a. But please bear with me, my pen, I don't know why, it's moving more than what's supposed to be. I think this will be charged. Right, so this will be x equal to minus 23 plus or minus the square root of minus 23 squared. Well, I've got a problem. Please, just allow me to start on a new page. I don't want to squeeze stuff so that someone doesn't see it properly. So let me do the substitution on the next page. Let me do the substitution on a fresh page. Okay, please be aware that the factorizing by a common factor which I did here is not necessary. Okay, if you want to use the quadratic formula, it's not necessary. Yes.
X squared minus 160 is from there.
The quadratic formula. Okay. Any question? So, let's do the substitution. So x will be minus 23 plus or minus the square root of minus 23 squared minus 4 times 25 times, okay, the constant is 24. Sorry, that should be a 5. Wait, okay, 4a, that's 5 times 24. Okay, it shows that some people are following what's happening. Like that will be 2 times 5. So that will give me 23 plus or minus the square root of, what's 23 squared? So that will be 529 minus, that's 20 times 24, that will be 480. Okay, so that will be all over 10. So eventually, our discriminant is going to be a perfect square. Okay? Please be aware that this is the discriminant. Whatever number we are going to get there, that's our discriminant. Okay? So this will give us 23 plus or minus the square root of 49, which is a perfect square. What this means here, our two solutions, okay, for the quadratic equation, not for the square root equation, they are going to be rational roots, and there are going to be two rational roots that are unequal. So this will be 23 plus or minus 7 over 10. Okay, so if I add those two, I'll get x equal to 3, or 24 minus 7, that's 16. So I'll end up getting 8 over 5. Okay. All right, so those are our two solutions. Yes. Yeah, then we need to substitute those two back here. We have to check here. Right, so we need to take out the calculator here and let's check. Okay? Are you following here? Huh? Huh? Okay, so let's start with x equal to 3. So if I put x equal to 3 there, I'll get 15 plus 1, which is 16. Okay, so I can put my 16 there. Then on the right hand side, if I put 3 there, I'll end up getting square root of 16 plus 12. So that will be square root of 16 plus 12. Fortunately, this will give me 16 as well, which means that's a what? A solution. Do you see that? The square root of 16 is a 4. 4 plus 12. You get what? 16. Okay? So it means x equal to 3 is a what? It's a solution. Now we need to test. X equal to 8 over 5. And now x equal to 8 over 5. If I put 8 here, I'll get 40 over 5, which is actually 8. 8 plus 1 will give me a 9. So I'll end up getting 9 on the left hand side. Then if I put the same 8 there, I'll also get an 8 plus 1. Then I'll get a 9. So square root of 9, so I'll end up getting square root of 9 plus 12. And this will give me 3 plus 12. So I'll get 15, which means this is not possible. Right, so this is not a solution. Okay, so that's not a solution. So this one we can say invalid, you have to specify that the other value of x is invalid, or you can just write not applicable. That's all. Okay. In the end, it means our solution here will be x equal to 3. So we have one solution. Are you following? Yes. What? Yes. How would one know that the other solution is invalid? Or if you want, this will also be acceptable. You can indicate that x is not equal to 8 over 5. That's also fine.
So you can give two values when you say one is equal to the other is not equal to
Yeah. All right. Okay. Let's have a class exercise. If you did the question, so this one is very straightforward. You just square both sides and you treat the x plus 4 as one number. So you square it like that. Then you get 2 minus x equal to x squared. That will be plus 8x plus 16. Right? Then you get 0 there. Then you have x squared plus 9x plus 14. Well, I think that can be solved by factorization, so that will be x plus 7 times x plus 2. So the two values of x will be x equal to minus 7 or x equal to minus 2. Okay, then we have to check those two values if they are both valid. So if I substitute x equal to minus 7, I'll get the square root of 9 inside the brackets. So inside the square root, then I'll get minus 7 plus 4, and this will give me 3 equal to minus 3. So this one here is not a solution. Okay? I hope you saw that. Right, then if we substitute x equal to minus 2 there, we'll get the square root of 4 equal to, you put minus 2 there plus 4, so we get 2 equal to 2. So what this means is this is a solution. So we can conclude and say therefore x is minus 2. Yeah. Yes, it's very possible. It's very much possible. You can also have a case where both values of x can be invalid. That's also a possibility.
What do you write as your statement? You say therefore x.
You just said therefore the square root equation doesn't have a what? A solution. That's all.
So it's possible that both values.
Yes, it is possible. But generally, when we give you a test, we won't give you a. I can't rule it out, but the probability of getting one where, hey, I don't like learners who talk without control. Was he as something very important. Like most of your questions that we will give you, there will be at least one solution. Okay? But the probability is very, very low that we give you a question where both x values will not be solutions. Right. In terms of mark allocation, this is important. What we look for are the following. Have you squared both sides to eliminate the square root sign? Right? Then we may give you a mark for simplifying, that is removing the brackets. Okay? It's not always, but the standard form these two, the ones which I'm putting 2 ticks, they are extremely important. You cannot skip those. You cannot skip those. Right? And your factors, you can't skip them. The factors, okay, they can also be replaced by the use of the quadratic formula. So we'll give you a mark for substituting correctly into the correct quadratic formula. Then we can give a mark here for both x equal to -2 and rejecting x equal to -7. So these two can be allocated 1 mark, which means a question like this can be 4 marks, maybe maximum 5 marks, but 4 marks. This step here is not that important, okay? But it helps you to get to the standard form. So you can have 4 marks or 5. If there are 5 marks, then this one would definitely be allocated a mark. Okay. All right. Can you try this? Therefore, I'll say let k be equal to the square root of x plus 8. Once I say k is equal to the square root of x plus 8, it makes things easier because the original equation will become k equal to 12 over k plus 1.
Is there any grade 12 regroup that would like to donate that? Please come down to the hall.
So once you get here, it should become easy to you. Hey, can you pay attention? The denominator there is a 1, denominator there is a 1. So obviously the LCD is going to be k, right? So what you can do, I'm not sure whether you're aware of this. If you want to create the quadratic equation, you can multiply every term by the LCD. Okay? So this becomes k times k over 1 is equal to k times 12 over k plus k times 1 over 1. The left-hand side becomes what? K squared. And these two here, they will cancel out. Okay, I'm just showing you from the basics how you end up having the 12. Okay, so this becomes 12 and that becomes a k. Okay, then you create your quadratic equation. So this will be k squared minus k minus 12 equal to 0. Right, then from here now, in actual fact, once you get to this point here, it's a grade 9 quadratic equation. Imagine if you have got a brother or sister at home and they ask you, can you help me to solve this? And then you can't help them. They won't be proud of you. They won't be proud of you. You're laughing, I'm serious. If you've got a brother or sister or maybe a cousin who is doing grade 9 and they come to you and say, can you help me to solve k squared minus k? Okay, in grade 9 they don't use k, normally it's x. X squared minus x minus 12. Imagine you struggling to help that kid. Imagine. Yeah. So they have to be proud of you. So this will be k minus 4 times k plus 3. Okay. Then we'll get two values here, k equal to 4 or k equal to minus 3. Okay. Now remember, our original equation is in terms of x. The original equation is in terms of x. Therefore, we need to substitute these two values of k here. If we substitute there, it means we are going to have two square root equations. Okay? So, when k is 4, you get k equal to the square root of x plus 8. So that means we get k squared equal to x plus 8. Okay, we can square them. Right? So that, now please take note, you have to square both sides.
Yes.
Isn't that correct?
Yes, sir. Yes.
Yeah. Then you get, sorry. And then I'm going to substitute my k, so that will be 4 squared equal to x plus 8. So you get 16 equal to x plus 8. Alright, okay. I realize that some of you, you wanted me to put the 4 straight away. Okay, it's fine. Whichever way you might have done it. Either you put the k in square first, then you substitute 4. It's the same thing. Right? So eventually we get x equal to what? 8. Then we need to check this. Okay? Let's check if it's valid. So, you go back to the original, please, you go back to the original equation. Okay? Remember, we found x. We found x equal to 8. You don't test with that. You test with the original. That one there. So if I put 8 there, I'll get square root of 8 plus 8. This is equal to 12 over 8 plus 8. That's the square root plus 1. So this will give me 16 equal to 12 over, okay, that's a 4 plus 1. Right? So you get a 4, and here you also get a 4. Okay? Please be aware that you have to substitute the x into the original equation. Okay? Okay. Then, when k is minus 3, when k is minus 3, so we get k squared equal to the square root of x plus 3, so x plus 8. So that will give us k squared equal to x plus 8. Then we substitute. So you end up getting a 9. A 9 equal to x plus 8. So x will be 1. Okay? Then you do some checking. If you do the checking, you substitute back into the original. So that will be the square root of 1 plus 8 is equal to 12 over the square root of 1 plus 8 plus 1. Right? So this will give me a 3. And that will give me 12 over 3 plus 1. So you get 3 equal to 5. Now this is not possible. Okay, so what that means is this is not a solution. X equal to 1 is not a solution. Okay, so the answer, okay, let me just write it in green. So our solution to this equation is going to be x equal to 8. That's the solution. Okay. Yes.
Beginning of the equation, should you specify that x is not equal to negative 8?
Which equation?
At the beginning of this one.
This one here.
No, the initial equation.
Okay. Yes. Okay. You can specify. Please take note of this. If you go back to the original question. Yeah. Can I have your attention, please? You might have to put a restriction there that x is not equal to negative 8. Okay, because if x is negative 8, it means our denominator will become a 0. Okay. That will help you as well if you are doing the checking. Okay, you might have to specify. But fortunately for this question here, our x has to be a positive 8. But specifying it is important. I think I forgot to do it. Yeah? Right. Please make sure you check whenever you've got a denominator which has got a variable, always write a restriction. Okay.